Okay, so forces. Forces are going to be pretty easy. Forces, it's very basic. Forces are a push or a pull. Uh, the most easiest one is literally someone comes up or something gives an object a push or a pull, like a kick or uh, any type of shove. There are also things that can do it invisibly. You don't have to touch the object. The most obvious one is the pull of the gravitational force. Pull of gravity, that's a force. You don't literally have to be touching it. Another one is magnetism. Magnetism is a force, can be a push or a pull, um, but it's an invisible force. Also, electricity. Electricity is an invisible force. Now, again, those can be both pushes or pulls. Like, magnets can push away from each other if they're on the same side or they're attractive. Same thing with electricity. If it's the same charge, they go away from each other, but if they're the opposite, they are attractive, and those are invisible, meaning they don't have to touch. But a force, push or pull, most basic definition. Now, there are two types of forces. Forces are classified as either balanced, and it's exactly what it sounds like, meaning everything's equal, or unbalanced. Now, if there are balanced forces, you have to remember that doesn't mean there are no forces. Balanced forces just mean overall there's no force. But there's always forces acting on an object. For example, there's always gravity acting on you. Always. Forces occur in pairs. So gravity's pulling you down. You are actually pulling back on the earth. Obviously, the earth wins, but you're pulling down. If you're sitting in a chair, you're pushing down on the chair is pushing up on you, keeping you stationary. You're not falling through the chair. When you stand on the floor, you push down on the floor pushes up on you. It's not quicksand, you don't fall through it. So forces a lot of times are in pairs, and they often are balanced, but not always. Obviously, if something's unbalanced, that's where we're going to see an overall force. They don't cancel each other out, or they're forces working together to make an even bigger force. So, if we're going over what is the definition of an unbalanced force, forces are unbalanced if their net force is not zero. Some common examples or things that you need to know. Unbalanced forces, you need to think of things like it's starting to move. If it stops moving, your car comes to a stop at a stoplight. If something changes in the direction, maybe you say you take a left turn, a right turn, you make a U-turn, you start going backwards. If you speed up, increase your speed, decrease your speed, slow down. All of these come to unbalanced forces will cause motion to change. All of these are examples of something changing about motion. So the motion of the object changes when you have unbalanced forces. Now, the big word you're going to hear a lot with unbalanced forces is the term acceleration. Although when we think of a car accelerating, we only think of the speed increasing. In physics, the term acceleration means motion changes. So actually, any of these, starting to move, slowing down, changing direction, all of these are examples of changes or are examples of acceleration. Balance forces, opposite, it's when the forces are equal and opposite, and they cancel out. So when we look at the force on the object, it's as if the force was zero. This does not mean there are no forces, it just means they're balanced and they cancel out. Balance forces will not change motion. So unbalanced causes a change in motion. Balanced forces, no change, no acceleration. Now, obvious one, balanced forces are going to be, objects will be still, motionless, not moving. But the other thing is that an object that's moving with balanced forces, which is possible, will be at a constant speed. So a lot of times we'll use the word constant motion with balanced forces, because that means stays the same. So for example, if you're in your car, you're in a school zone, your parent might put on the cruise control. Cruise control meaning it keeps your car at the same speed no matter what. So that would be balanced forces. Your car is staying at the same speed. It's moving, but the forces are balanced, so there's no change in your speed. So unbalanced forces cause a change in motion. Balanced forces, no change. Often these objects with balanced forces are still, or they're in constant motion. So you're going to see some examples like this. Most of the time we see just boxes instead of actually drawing out the truck, but the first example is where you see the two forces. They're going opposite directions. One's going right, one's going left. They're the same amount, so these would cancel out because 100 minus 100, 0. No net force, so this is a balanced force on the truck. In this case, the truck is going to stay still. The second one, this truck is experiencing unbalanced forces because we have 100 newtons to the left, only 60 newtons to the right, so I have an overall force of 40 causing this object to change its motion. And it is going to change going to the left direction because that's the bigger force. Now, on this cruise ship, these are examples of balance forces. The boat is not sinking, it's staying at the same spot on top of the water. And so these would represent that gravity was pulling down, but the buoyancy or the floating aspect of the boat is keeping it up. So they're balanced, they're opposite direction, they cancel out, so this is a balanced forces. They're equal and opposite, making them overall 0. Now the boat could still be going forward, but we're talking about it's not sinking. The Titanic, when it sank, obviously did not have balanced forces because gravity pulled it down and won. Another example is this vase is sitting motionless on the table. That means it's not moving, so it's balanced forces. The gravity is pulling it down. The table is pushing it up, keeping it balanced, not moving, same, equal and opposite directions. Now here's the similar example. These are unbalanced, so the truck has a force going forward of 100 newtons and a force pushing it back, maybe friction, air resistance of 60. So there is a force on the object. It is unbalanced, so the truck is going to speed up. There's that change, so it's going to accelerate in that direction.